Hello, in this video we're going to be looking at solving equations with fractions, method 2. If you watched the previous video that I called method 1, you got to see us solve some equations that had fractions in them. This method, method 2, is another way to approach those exact same problems. You're going to see the same problems that I worked in the previous video. This method is one I kind of nickname how to solve equations with fractions for people that don't like to work with fractions. Now, in fairness to the last video, I'm going to go ahead and go over the same vocabulary. We are going to talk about inverse operations, or doing the opposite of whatever operation you're looking at. You see addition. The opposite of addition is subtraction, and the opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. That still holds true. Nothing is changing about our procedure on how we're going to be able to work with things. It's just this time around, the first thing we're going to do in every single problem is get rid of the fraction. So in this first problem here, I'm looking at x plus 1/9 equals 7/9, and I want to call your attention to the denominator. Both fractions have the same denominator. It's a good place to start. And what is that denominator? It's 9. So what we're going to do, and this might look a little bit strange to you at first, and I'll explain it in a second, but I'm going to multiply everything by 9. Now, I did this as kind of a shorthand, real quick way of doing it here. The reality is what we're about to do is we're going to do 9 times x plus 9 times 1/9 equals 9 times 7/9, which is an awful lot to write. If you want to write that, there's nothing wrong with it, but this is going to be the only time I'm going to write the whole thing out during this video. But if you take a look and we do 9 times x, well, just like we wrote over there, that equals 9x. Plus, and then we're going to do 9 times 1/9. In this case, and I'll come back to the picture we have here, the 9's cancel. That leaves you with 1. And then finally, we're going to do 9 times 7/9. And I'll come back to this picture that I drew here. The 9's cancel. You're left with 7. We have 9x plus 1 equals 7. It's much like a problem that we would have worked earlier. So I'm going to go ahead and put in my balance line. I'm going to run out of a little bit of space here, so I'm going to have to finish up my work in this section. But the first thing we want to do is get rid of the addition. We'll do that by subtracting 1 from either side. That's going to give us 9x equals 6. And then we'll divide both sides by 9. X equals, and the number 3 goes into 6 2 times. The number 3 goes into 9 3 times. And just like we did on that last video, I get x equals 2/3. Same answer, but I never had to add any fractions together. Now, that may have not been a major concern of yours when we did this particular problem the first time with method 1, but when we came back to this problem, if you remember, there may have been some issues because we had to create like denominators. So just like on the last problem, let's look at our denominators. We have the number 5 and the number 2. If I multiply that together, I get 10. And that's the key to this problem. We're going to multiply everybody by 10. And you know, I said I wasn't going to write it out, but I think it'll be helpful for you if I went ahead and wrote that again. We're going to do 10 times 3/5 plus 10 times x equals 10 nice space there, times negative 1/2. 5 goes into 10 2 times, and 2 times 3 is 6. 10 times x is simply 10x. And finally, 2 goes into 10 5 times, and 5 times negative 1 is negative 5. And where before we had an equation that involved fractions, we no longer do. We have a problem just like the ones we've worked in the past. We'll begin by subtracting 6 from both sides. That gives us 10x equals negative 11. Divide both sides. Divide both sides by x. And just like before, we're going to find that x equals negative 11/10. You may have noticed that I'm not really going through and checking the answers. Since we've already worked these problems before doing method 1, you can see that we did check the answers at that time. And just for time's sake, we won't be doing that with this video. But the same rule is going to apply here. Even though multiplying by the reciprocal or using the keep, change, flip method may have not been any kind of an issue to you, we can still use the same method here. We're going to multiply everything by a single number to get rid of those denominators. What number do you think we're going to use? Well, the denominators are 5 and 3, and 5 times 3 is 15. So that's what we're going to multiply everybody in this problem by. 5 goes into 15 3 times. 3 times 4 is 12. X equals, and 3 goes into 15 5 times. And 5 times 2 is 10. We have 12x equals 10. And if you're a little shaky on using keep, change, flip, or multiply by the reciprocal, hopefully this simplifies it a lot for you. We're just going to go ahead and divide both sides of the equation by 12. So x equals, well, let's reduce the fraction. 2 goes into 10 5 times, and 2 goes into 12 6 times. I get the answer 5/6, the same answer we got last time. And we really didn't have to do much with fractions. And finally, for this last problem, we do still encounter this 5/1. That's important to notice because the denominator is 1, and it is going to affect what we're going to multiply everything by. And what's that going to be? We have a 1 and we have a 7. Just multiply everything by 7. 1 goes into 7. We don't even really need to consider that. But 7 times 5 is 35. It's 35x. Equals 7 goes into 7 one time. And 1 times 6 is 6. All we have to do now is divide both sides of the equation by 35. 6 and 35 don't have anything in common. So just like we did on the last video, we're getting that x equals 6/35, or 6/35. So we'll box that answer for easy tracking later. And that's method 2 for solving equations that have fractions by just getting rid of those fractions.